All right, AP Stats, are you ready for Unit 2? So Unit 1 was one variable data. Unit 2, we're going to be talking about two variable data. So we opened up Unit 1 talking about situations where we have two variable data, but now we're going to dive into the specifics. So starting off, scatter plots is what we're focusing on today. Pretty easy concept, and I think you will enjoy it. So our learning objectives, we're going to distinguish between an explanatory and a response variable. For quantitative data, meaning both data has to be answered with a number. We're also going to make a scatter plot to display the relationship between the two quantitative variables, and we're going to describe the scatter plot. All right, so part 1, explanatory and response variables. So these are terms I'm sure you've heard before. Response variable measures the outcome of a study. Explanatory variable may help predict or explain the changes in the response variable. So my explanatory variable explains the change. We would also call this the independent variable. And the x value. So that would make the response variable the dependent variable because it depends on the explanatory, right? Dependent. And the y value. The x and y value are important to differentiate because when we actually plot the scatter plot, we always want the explanatory value on the x value. All right, so let's think of an example. Let's see, explanatory and response. How about, let's see if there's a correlation, or I'm sorry, a relationship between the amount of times you laugh and the number of jokes I make, right? So which would be the response and which would be the explanatory? The number of jokes I make and then the number of laughs you laugh at home. Which one explains the other? And we're going to assume I am funny. That's an assumption you must make. I'm sorry about that. So what comes first, the jokes or the laughing? The jokes. Number of jokes I make number of laughs from you. The jokes explain the laughs, right? All right. Now some main ideas here. We don't specify the value, when we don't specify the values of either variable before collecting a data, there may or may not be a clear explanatory variable. So there could be situations where you cannot identify what's the explanatory variable and what's the response variable. So you're not sure which comes first or which is the explaining, and that's fine. Number 2, in many studies, the goal is to show that changes in one or more explanatory variables actually cause changes in a response variable. Because what's the whole point of statistics if we're not using all these numbers to show causation and show relationships? So that's the ultimate goal, right? We want to prove that one explanatory variable causes a change in a response variable. All right, let's get to some examples. I'll do example 1 with you, then I want you to pause and try example 2 and 3 on your own and then come back to me. I'm going to do every single problem in the packet, but I want you to try things on your own before getting your answer. All right, number 1, how does drinking beer affect the level of alcohol in our blood? The legal limit for driving in all states is 0.08%. In a study, adult volunteers drank different numbers of cans of beer. 30 minutes later, a police officer measured their blood alcohol levels. All right, which one explains the other? Does the blood alcohol level explain the number of cans, or does the number of cans you drink explain the blood alcohol level? Which comes first? That would be the explanatory variable is the number of cans of beer consumed. And then our response variable is our blood alcohol level. Notice they're both quantitative, right? Number of cans of beer, and our blood alcohol level is a %. All right, go ahead, pause the video and try example 2 and example 3, and then come back when you're done. All right, example 2. The National Student Loan Survey provides data on the amount of debt for recent college graduates and their current income and how stressed they feel about college debt. A sociologist looks at the data with the goal of using the amount of debt and income to explain the stress caused by college debt. All right, so looking at this explanatory variable and response variable. So this one's pretty easy because it's actually got the word explain saying this explains this, right? So we have 2 explanatory variables here. We have debt and income, right? Debt and income. Notice those are both quantitative, right? Your debt and your income would both be in dollars. And then explain the stress. So your response variable is stress. Now you would think, is stress a quantitative variable? Well, when they measure stress, or when you go to the doctor and they measure some sort of feeling, they ask you like what? On a scale of 1 to 10, how much pain do you feel, right? So I assume they'd be doing the same thing here. On a scale of 1 to 10, how stressed out are you? And I would always answer with a 15. All right, example 3. How does the fuel consumption of a car change as its speed increases? A study measured speed in kilometers per hour and fuel consumption in liters of gasoline per 100 kilometers traveled for a sample of British Ford Escorts. All right, so how does fuel consumption of a car change as its speed increases? All right, so it looks like explanatory variable, speed, response variable, fuel consumption. And let's think about how we would think the relationship would work. The faster the car goes, the more gasoline it consumes, right? The slower the car goes, the more gasoline it saves. So always think which explains the other. All right, go ahead, turn it over. All right, getting into the scatter plots. Okay, so scatter plots show the relationship between 2 quantitative variables measured on the same individuals. So one variable, the explanatory variable, goes on the x-axis, and the response variable goes on the y-axis. Each individual in the data set is a point on the graph. So we don't have actual labels here, so we don't know what we're measuring, but every single point here is a person who had this as an explanatory variable and this as a response variable. So in our number of beers and blood alcohol level, this would be about 22 beers and about a 26% blood alcohol level. Now that's not a real thing, I'm just using that as an example so we could interpret one of these dots. All right, and then when you're creating a scatter plot, you always want to make sure you label both axes, right? And you're labeling it with the correct numbers, and you're labeling it with the explanatory and response variables. You also want to title it. And you want to scale correctly. So do you see the scale here is we're going by 5s? The scale here is we're going by 5s. All right. Describing scatter plots. All right, so when we talked earlier in Unit 1 about describing distributions, you automatically know when you see that on the AP exam. Describing distributions, you think of those 4 letters, right? SOCV. Describing scatter plots has the same sort of prescriptive formula. There's certain things that you have to talk about when you're describing scatter plots. The first thing you talk about is pretty easy. Direction. Positive association, negative association, or no association. So, positive association is when the variables go the same direction. Did I spell direction right at all? How about I go over here? Same direction. I'm just going to erase that mess. All right, a negative association is when they go different directions. So with a positive association, they could both be going up at the same time, or they could both be going down at the same time. With negative, the explanatory goes up, the response goes down, or as the explanatory goes down, the response goes up. So I don't want you to get thrown off on positive if they're both going down, you think, oh, that must be negative. No, it's whether or not they're going the same direction. And the no association is no association. All right, so let me do one example here, and then I want you to pause the video and try the other examples. Okay, A, time spent exercising and weight in pounds. All right, so thinking about this, time spent exercising. So let's just go ahead and see if we assume that the explanatory variable goes up, what happens with the weight? As the time spent exercising goes up, we would think that our weight should be going down, right? So it looks like we're going two different directions. Is that positive or negative? That would be negative. All right, go ahead and pause the video and come back once you've done B through F. Okay, number 2, or B, I'm sorry. Hours of sleep per night and number of friends. Well, this one should have no association. No association. The number of hours you sleep at night and the number of friends you have really don't have any sort of relationship, I would think. All right, advertising dollars and sales amounts. All right, Miss King's class in 3DE, you should definitely know this. Advertising dollars. All right, as the money that we spend on advertising goes up, what should happen to sales? Sales should also go up. If we're advertising, that means our sales should also go up. So both of my numbers are going up, same direction. They have a positive relationship. Now the same would be true the other way, right? If my advertising dollars go down, my sales would also go down. All right, D, number of household pets and high school GPA. You should have said no association. All right. E, temperature and ice cream sales. All right, so let's think. Outside, it's 90 degrees still in September. So as the temperature goes up, as it gets hotter outside, what happens with ice cream sales? They would also go up. As the temperature goes down in the wintertime, ice cream sales would also dip, right? So if they're going the same direction, you've got a positive relationship. All right. Average age and the average amount of hair in males. All right, if you have trouble visualizing this, we're going to call this the Mr. Patterson problem. All right. So as age goes up in males, as they get older, what happens to the amount of hair they have? It goes down. They lose their hair. So as their age goes up, their hair amount goes down. We're going different directions. So that is a negative association. All right. So this is my direction. This is the first thing you would have to describe when you describe a scatter plot. Positive, negative, or no association. All right. Go ahead and go to the second video and we'll finish all the different parts about describing scatter plots.